Let's try evaluating the limit as x goes to 0 of sine squared x over x squared. We actually learned how to evaluate limits like this using those special trig limits. But L'Hopital provides us another way. If we substitute in 0 for x, we would get sine squared of 0 divided by 0 squared. Sine of 0 is 0. So we would get a 0 in the numerator and a 0 in the denominator. Since we have indeterminate form, L'Hopital's rule applies. We need to take the derivative of the numerator. It might help if we rewrite sine squared of x as sine of x squared. That way we can see that this is a chain rule problem. The outer function is the parentheses squared. The inner function is sine of x. So the derivative of sine of x, quantity squared, would be 2 times sine of x. And then we have to multiply that with the derivative of the inner function. Derivative of sine is cosine. Separately, we find the derivative of the denominator. Derivative of x squared would be 2x. Now we try direct substitution again. I plug in 0 for the x's. In the numerator, sine of 0 is just 0. So that means that 2 times 0 times 1 would be 0. And then in the denominator, 2 times 0 is 0. Once again, we get indeterminate form. That means L'Hopital's rule can apply again. So we will take the derivative of the numerator and the denominator separately. In the numerator and the denominator, we had a common factor of 2, which means those could have reduced. So then for the derivative, I'm just going to take the derivative of sine of x times cosine of x. This would be a product rule problem. I'm going to leave the first function the same, and then multiply that with the derivative of the second function. And then I want to add it, take the derivative of the first function, and leave the second function the same. And then separately, I take the derivative of the denominator. Derivative of x is just 1. We try direct substitution. If I substitute in 0 for x and sine of x, I would have sine of 0, which is 0. So that would be a 0 times a negative 0. If I substitute in 0 for the x inside of the cosines, that would give me a 1. So I would have 1 times 1. 0 plus 1 over 1 is equal to 1. Let's try another example of evaluating a limit where we would apply L'Hopital's rule. Let's say if we have the limit as x goes to infinity of 4x squared minus 3x all over 6x cubed plus 5x squared. When we evaluated a limit like this in Unit 1, we would have looked at the degree of the top and of the bottom separately. If the degree of the bottom is bigger than the degree of the top, we would have said that this was equal to 0. That's because as you plug infinity into this, the denominator would get a lot bigger a lot faster than the numerator would. So the whole fraction would trend towards 0. But let's try evaluating this limit a different way. First, we can try direct substitution. If I substituted in infinity into the numerator, I would have 4 times a huge number squared minus 3 times a huge number. So that x squared would get bigger faster than the negative 3x would. That means the numerator would trend towards infinity. In the denominator, if I plug in a huge number for the x's, I would have 6 times a huge number cubed plus 5 times a huge number squared. So the denominator would also trend towards infinity. Since I end up with infinity divided by infinity, that means L'Hopital's rule applies. We're going to take the derivative of the numerator and the denominator separately. Derivative of 4x squared minus 3x would be 8x minus 3. And then the denominator of 6x cubed minus 5x squared would be 18x squared plus 10x. If we try to evaluate this at infinity, the numerator would be 8 times infinity minus 3. So the numerator would be infinite. The denominator would be 18 times infinity squared plus 10 times infinity. So the denominator would also be infinite. We would have infinity divided by infinity, which is indeterminate form. That means we can use L'Hopital's rule again. We're going to take the derivative of the top. The derivative of 8x minus 3 is 8. And then the derivative of the bottom. Derivative of 18x squared plus 10x is 36x plus 10. If we try direct substitution again, we would get 8 divided by an infinity. And 8 divided by infinity is equal to 0.